Welcome back to my channel, and today I'm going to be using this research dataset on the tumor's eyes and its impact on how long somebody might stay in the hospital after surgery. And so the last time we were together in a video, I shared these lines of code with you of importing the dataset, and we talked a little bit about the different variables that were in the dataset. And so I'm going to rerun the dataset into this program so at least I can begin talking about some new things. And again, we noticed that there were 20 records and 16 different variables identified in the dataset. And I won't repeat that today, and looks like case got 14 here. I think we want to have that P16. So let's correct that error, and we just again do some double checking that we're dealing with the data frame, and I want to attach it so I can make my typing be a little less onerous. And remember, over in the right-hand corner is what we're shooting for in the next few days, for me to use my data frame and my data Saturday to frame to actually begin to plot some of this medical relationship that exists in the data set, similar to what you're doing in Build-Trout RML2. And by the way, I'm going to clear out my console here with a Control L so things are nice and tidy for us to begin. And as you would expect, I begin by doing some basic things. I want to take a look at the mean tumor size of the patients that we have in 2015 versus those in 2020. I want to look at the variation in tumor size. All that looks pretty good. We have a pretty good match of patients 5 years separated. They are different patients, of course, but the tumor size is about close, as well as the standard deviation. So I'm pleased about that. And then in terms of days in the hospital and reviewing the data set, we also see we have a big difference in the mean days. And that's really what we want to explore. And we're going to eventually take a look at what are the possible explanations for why the mean day in patient in 2020 was so much less the mean days in 2015. And is that change from 12 to 6 significant? And the variance also may be significant, having dropped from 4.19 down to 3.51. So those are the kinds of things that we typically are beginning to ask ourselves. Are we beginning to learn some things from the data about the population and how we may treat future patients? And so let's just take a look at some other basic information I hear. I create a linear line, actually a linear regression line, which we're not going to look at this moment, but I am going to show you that this is just a linear equation that I'm getting where I'm beginning to identify the interception point as well as the slope of a linear regression line. And we'll come back and talk about that a little bit later. And we'll also talk a little bit about the statistics associated with this line. What we really want to begin to look at is plotting, because that's your main goal of right now in working through Build-Trout RML2. So my first plot was a very simple plot, and it's a scatter plot, plotting long tumor size against inpatient days. Certainly looks like there's a reasonable correlation if I drew a linear regression line through here. While the lines and the data, we don't know too much about how they really are in terms of male, female, for example. They certainly are forming a positive slope. Is the correlation going to be very strong? Well, we don't know a lot yet about correlation nor regression, but I will be sharing some numbers like that as we go forward. So I'll give you a little bit of a hint about what you're going to be doing on this channel. But at least right now, we have a plot, and that's important for us. And let's talk a little bit about how do I got that plot. Most of you now know how to do a scatter plot. Days 15 till D. In this we're using the plot routine, by the way. This is going to be the dependent variable. Tumor size 15 will be what we call the independent variable or the x-axis variable. And notice that I set some limits so that I don't have a, a disproportionate amount of white space, or I don't crunch points or drop some of the points. So I want my limits are going on the x side. For tumor sides are going to go from about 4 centimeters up to about 14. And then my limits on the days in the hospital will go from about 0 up to 20 or so. And then I put in a label on the y-axis and a label on the x-axis, long tumor size. That's always nice to do. Otherwise, you're going to get labeled the variable name rather than some nice nomenclature that you choose. And then finally, we have some variables here called PCH, LAS, CE, X, etc. And I want to talk a little bit about them in my very next video. And that will focus a little bit on these different, if you will, variables that I can identify, or parameters, if it was a better term, that I can identify, want to use in plot. So I think that will do us to get us started.